June 2019, I am making some theory about the ferromagnetism and in relation with magnetron or cyclotron principle for free energy. I summarize the previous video that I have uploaded shortly to make a continuous story. So in the previous video, I said it's very unlikely that the nature provides both polarity of charge. There is some plus part, there is some minus part. It's quite hard to imagine both polarities are provided from the nature. And I also gave an example of misunderstood Tesla radiant particle collector. So this kind of particle collector cannot be one polarity particle. For example, I think Tesla also said a neutrino coming and hitting. Yeah, so if it is like this, a single polarity here accumulated, without having the counter charge accumulated here, there is no electric field. So that's why single charge cannot be energy, single polarity. Or if it is this kind of high energy particle, then the structure has to be a bit different, which should look like a solar cell. So which means the high energy hits, then there is a separation of electron hole pair. So when the electron hole pair recombines, then it becomes energy, but not this kind of structure. And I also said if nature provided the plus and minus both enough, then you don't need over unity device to make a signal generator. You just need to put the load in between. So that's what I said. So the only hope is we have to harness energy from single polarity static charge. There is enough static charges. So how do we do that? So to harness this energy, we have to know that this one to harness this, it has very slow velocity. It could be large number of charges, but it has very slow velocity. That means when it has a Coulomb repulsion and then it diffuses away, then it has a very low velocity here, and we have the harness from here. So let's say the open coil, there is a static charge accumulated, and then we want to harness this energy, and then we put in the coil like that. And then let's think about this later. So it's making the diffusion current, which means just charge accumulated here is moving from here to here. So diffusion current is a very slow velocity. So this diffusion current has to be accelerated through this and this principle. So that's what I'm hoping. So to have this, we have to know about the bifilar coil. Bifilar coil is so there is a signal, and then bifilar coil is like that, and then if here is 50, then here is also 50. It's 100. So there is always voltage difference, uniform voltage difference between one coil and the other coil. So we can utilize this when we harness this energy, and then it's gonna make a long story. Let me draw the coil with a bifilar, and then I'm gonna draw like this. So coil is wound, it's a coil number 1, and then coil number 2 is wound like that, and then we need another coil, which is this source. So coming here, and then let's say it's wound in between the coil, in between the bifilar coil. So if I show the example like that, so let's say the copper one is the source of energy, free energy, and then each this is the bifilar number 1, and then this is the bifilar number 2, and then in between here the source coil comes. Then what we can imagine is there is an electric field because of the voltage difference. Yeah, it's making the electric field, and then the B field is AC. So there's a B field because this and this coil is running like that with AC. So there's a B field. So that means there's a B field coming in, out, in, out, in, out through the bifilar coil. And then this source coil came from the free energy part. And when this charge comes here, and when it sees the electric field, it wants to just go to this part. So there is no energy, nothing serious energy. Then what we can do is, if we give some magnetic field so that it has the force direction here, then now it's gonna accelerate like that. If it has accelerated like this way, like a cyclotron, then this B field will be enhanced. So it's like a magic. So let's have some schematic. Actually, it's easier to understand if it is the pancake coil. Okay, so pancake coil, and then if it is this is a resonating coil. Resonating coil goes to have the second winding. It's like that approximately. And then let's imagine we put a large magnet here on top of that. And then the magnetic field is putting this. The free energy source is here, static charge, and then it is just diffusing and then slowly moving. That doesn't contribute much. But because of this magnetic field, it starts accelerating like that. When it accelerates, then it contributes to the B field here. When the B field is enhanced, then this resonant current is enhanced. So that's what I can visualize. And if it is this kind of shape, then when the B field is towards this direction, let's say the one magnet is underneath and then the other magnet is on top of here and then making this kind of B field. If the B field is here, then this free energy source sees electric field this direction, and then the B field this direction. Therefore, the vector direction is here, so it wants to flow more. If you put the magnet here and then underneath here, so B field is like that, then finally the current enhances. So that's what I think it's the only hope, to be honest, since I've researched about the free energy device. So because of this B field, it's enhanced. When it's enhanced, then this resonating coil B field is enhanced. When this B field is enhanced, then resonating current gets enhanced. So that's what I think. So the 90 degree B field can accelerate. Then how do we make 90 degree B field? That's the question. If it is this structure, then yeah, so you just need to wound like this, then it's a 90 degree B field can be made, which will be explained again in this structure. But in this structure, it's hard to make the 90 degree B field. You have to wrap around with a magnet like that. Then it can have B field, but obviously the Akula or Ruslan devices, they don't use that kind of magnet around the coil. So if it is the granite, so to speak, and then this is the inductor, so to speak, they name it like this way. Let's just follow this convention. Granite is the where the energy creating part, and then this is resonating part. So, and they don't put the magnets around. So how can we make the 90 degree field without putting the magnet like that? So one possibility is if you wrap around coil and then you give slow ALF, low frequency, you give slow low frequency, and then it's running, going, then through the bifilar coil. I'm not saying that you give running and going. You just give here bifilar coil running, going, and then so that the electric field is like that, and then the other direction like the other direction, and then with the B field it's gonna happen like this and like this. But if you give a shock like that, which I have confirmed actually, if you give a shock when you give the low frequency, then there is a B field creating like that. And before I explain this, I explain with this. If you give a shock with this, it's like that, then the magnetic field should be this. But if you give a pulse here, then not only the magnetic field happens here, magnetic field happens here as well. So a magnetic field is created this direction and this direction, which is the ferromagnetism. So because this magnetic field happening like that, so this part, this scattered magnetic field part can enhance the current flow coming from the free energy source. So this can enhance, and because it's enhanced, this low frequency magnetic field is enhanced. That's what I think it's called resonance by many people. So that's one way, and there is another possibility, which is this one. This one, so for example, you can give the magnetic field shock here. If you give a shock, then the magnetic field is not only this direction, it happens to this direction, and then you have to wind the free energy coil. The coil connected to the free energy, and then that will have some current enhancement. That's what I see. Or in this kind of device, there is antenna placed around this, and then this antenna is connected to the Tesla tower, so to speak. So if it's the Tesla tower, then I can imagine another type of the ferromagnetism happening, which means, let's say, so to speak, granite structure is like that, and then here is the resonant coil, which is the bifilar coil is wound like that, and then the antenna, this antenna is giving the, it's not B field, it's E field. E field shock is given like this way. In this scheme is normally is a megahertz, between 1 and 2 megahertz. This kind of E field shock is happening. Again, when there is a shock, it's not a smooth shape. When it's a sharp shock happening, then in this direction, E field direction, P field happens. So again, because of the bifilar voltage difference, there is an electric field like that, and then either in here you have to give a shock like that, or this Tesla antenna is giving the shock, E field shock, but because of the ferroresonance, there is a magnetic field happening to this direction. When the magnetic field happening like that, then it turns like that. So, okay. I'm talking about, so without magnet, how can we use AC to make the ferroresonance? So that was one way, was the LF shock, and then the other is Tesla tower shock. I don't know which is a better way, but let me follow the most famous scheme made by Ruslan and Akula. Actually, Akula made a lot of other things. Ruslan scheme, which was followed by, initiated by Kapanadze, and in this scheme they use the Tesla tower, and then high voltage is giving the shock like that. So that's the way how you can make the ferroresonance. Therefore, the free energy single polarity, it makes a proper current. So, however, to make this, I am realizing that the in this coil, the low frequency coil, the B field is like that, and in the Tesla is a high frequency. If you give like that, then it's nothing, because the current goes here and the current goes there, current goes here, current goes there, then there is nothing enhances. You have to give one direction shock, pop, 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 pop. So we have to use some diode to make this one direction shock, which means Tesla tower, and then there is the electric ground, which is connected to the tail of the Tesla tower. So when this shock happens, we have to have a diode here or somewhere, so that it's only one direction. It doesn't give pulse to the opposite direction, because once it's opposite direction, then this one turns to here. So that's what I think. Although because of this half, it's gonna make some current, but it's not that efficient. So that's what I suspect. What about the bucking field? So bucking field is another famous way. Go and then, am I right? Yeah, go like that. So the B field gets collided here. When B field gets collided, then again I think there is a ferromagnetism happening here. It's a shock. Okay, then where? How can we use? Yeah, so not in the Ruslan scheme, but this kind of bucking field can also make the current flow towards this direction. However, we need to be careful, because when the bucking like that and then like that, then would the current choose the path like this, or this one makes this one and this one makes this one? Looks like it's choosing one path, although B field is making like this way. So the reason is there is a famous device, MEG, so motionless electric or electromagnetic generator. So it's also using some bucking principles. So NS, and then when it has the blockage here, then it doesn't separate the magnetic field like that. It chooses one direction. So either it flows here, magnetic field, or flows there. So because of that, this bucking is another way to make the ferroresonance. Why do we make the ferroresonance? Because this slow velocity free energy current can be accelerated. That's the only way, only reason. Then how can we get the output? So in this case, it's like that. Then the output is a parallel coil, which means B field is like that, and then because the free energy has enhanced through the magnetic field like that, so because it's enhanced, the B field is enhanced, therefore more current coming. So that's one way of having output. Or there are devices having output through here. So normally TPU has two type of coil. One is the source of free energy coming here, and then that's the slow, like a very thick coil. Slow, thick coil coming here, and then it's connected to the bifilar coil here, and because of that, because it's giving the shock like that. So, or it can put the magnet on top of that. Because of that, this current is enhanced. When this enhanced, again, when it's enhanced, this current is also enhanced. So you can take the output from here, or you can take the enhanced resonance current here. So there are two ways to get the output. But in the Ruslan or Kappanadze scheme, there is no, I really don't think there is a perpendicular coil wound to get the output. Only, yeah, there is a unique, very nice case which made by Vasmus. Vasmus is using 90-degree coil. But I don't think he is depending on 100% with this output. So I think he is just using this coil to get some energy summation. That's why he says it's a summator. So he's still getting the energy from this direction, which is the parallel direction. But by connecting the pulse part through here, so he's getting a little bit more enhancement here, not to get the energy through here. So that's it. And then it's coming to more serious part, which is then what kind of frequency do we use? One frequency is slow frequency, which is for the resonance coil. And the other frequency, when you give the shock, when you can give a shock like that, as I said, so in that case, you don't need two frequencies, just one frequency is okay. But when you give this shock, and then that frequency has to be understood either NMR Rameau frequency or Magnetron frequency. It's still my question. Maybe I will find out in the near future. But if I just see the chemistry experiments, Rameau frequency is normally megahertz, and magnetron frequency or cyclotron frequency is normally gigahertz. We normally don't use this when we make the free energy. It's normally we are using this. So when you give a megahertz shock like that, then it's the spin is confused, and then it starts turning like that. So spin turning, one turn, speed is about megahertz. So the spin is not that fast. It's not like that. So spin turns much slower than we think, and then it's causing megahertz. However, in the magnetron is or cyclotron. Cyclotron is there is a magnetic field coming like that, and then it's turning like that. And this is really fast. When initially it turns like that, and then it gives another energy, and then add up. Then it's accelerated, and then it's also turning making a bigger circle, or microwave oven using the magnetron giving like that, and then it gets more energy and then goes out with gigahertz. So they are using the gigahertz. So I think it's more close to Rameau frequency. So spin is turning like that. But if I see the picture, it has to be more magnetron. So that means when electric shock is like that, and because of the electric shock, magnetic field is coming to this direction as well. Because of that, the free energy charge is turning, and one turn, and then it's moving to the other direction. So this one turn completing is close to gigahertz. It's all analogy. It's not exactly this, so that's why it's hard to imagine. But if I use just follow the magnetron frequency, then it has to be gigahertz, which I don't believe so. So it has to be somehow megahertz, and then the only chance is the nano frequency that's spin is turning by itself, not this long contour frequency. Spin is turning and then coming back to the original position is about that frequency megahertz. So let's stick to this. It's close to Rameau frequency, and what we have to know is again, so TPU direction. It's really interesting when you give a shock to the lateral direction. If you give a shock like that, then as I said, there is an output coming like that through this. So it's really interesting. However, there is so now I draw a picture. So if I give a shock like that, then this one gives this kind of shape output. Interesting. Yeah, because of the resistance and so on in the ferrite. So it's this. But what is interesting is if you give a shock like that, then at some frequency it makes this. So it makes this kind of shape. So I recommend everybody to experience about this. So therefore, when you give a shock, then there is something resonating. When it resonates, then there is a big wave included here. This is just when this is just going like that, then it's just not changing the frequency, and the same frequency comes out. However, this low frequency is coming. So I am just using this analogy and go here. So if you give a shock like that with a Tesla antenna, shock like that, then the magnetic field also has this direction because of the ferroresonance. And when you give this shock properly, then there is a resonance frequency, which means it's much slower than we think. And in this case, it was about 200 or 300 kilohertz. When I gave a shock like that, output this one is about megahertz, some megahertz, and then this low frequency is some 100 kilohertz is coming. So it's no way to calculate because there is no proper physics formula. So only through the trial and error you can find it out. So the last part, let's say I found out the frequency, and then so I can enhance the resonance. However, there is still a dilemma. So single polarity charge is used, and then it's accelerated, and because it's accelerated, the B field is enhanced, and that can be harvested. However, it's not a electron hole pair. So although it's moved here, so I need to find out a way to dissipate. Otherwise, when it's accumulated enough, and it wouldn't come. So this is the final dilemma that I have to find out the solution. So this one can be dissipated by putting some large reservoir of emptiness, And when it's like that, then it's slowly moving away and then emptying this bucket, hopefully. Or some counter charge comes really slowly to recombine and then empty the bucket. Which means I'm still saying that you need plus and minus source. I start from how can we harness the energy from the single charge, but still you have to sort it out. In my experiments, I saw the free energy. Free energy is really small, so that's why I couldn't make over unity device, but there's free energy coming from the earth, which means only sometimes some energy is coming like that. So, and this energy can resonate with the over unity device or Tesla device, and then nothing comes. And this is close to 50 kilohertz, 50 hertz. But I don't say 50 hertz energy is coming like that. I don't mean that. Just some signal comes, and that can be a different kinds of signal, but the period is close, not exactly close to 50 kilohertz, which means all the energy wants to come here. So one type of charge comes here, and because it needs time to dissipate or bring the counter charge, that's why it takes long time, and then coming here. And another clue that it takes a long time is when I do the free energy experiment, I have huge problem of the static charge accumulated in the circuit, and it breaks or it doesn't work. It stops working. Maybe lots of people have experienced that, because we are using the single charge, and then if we don't dissipate this, it's all around the circuit and then starts disturbing the function. So we have to find out how to dissipate this accumulated one. So, okay, let's say through the ferromagnetism on the magnetron, and then it's well harnessed, but has to go somewhere. Then can it be recycled like that? No, because we are using the force that it wants to diffuse away. Because I'm not saying that how it came together, which is the mystery part, but the free energy that I'm thinking is we are using this diffuse away part, and then that's just accelerated. Okay, that's it.